The next section in Chapter 6 is on proportions. A proportion states that two ratios are equal. So it's setting two ratios equal to each other. So here's one ratio. If I have $20 in 4 hours, an equivalent ratio would be $40 in 8 hours. So these are two separate ratios set equal to each other because they are equivalent. $20 in 4 hours is the same thing as $40 in 8 hours. So let's just look at some quick examples of how to write these sentences as proportions, and it's pretty straightforward. If I'm going to pay $7 for 3 cans, it's the same as paying $28 for 12 cans. So we can write that 7 to 3 cans equals 28 to 12 cans. So that's writing that sentence as a proportion. Same idea on the next one. 9 meters is to 16 meters as 18 meters is to 32. So 9 is to 16, the same as 18 is to 32. So it's writing two ratios equivalent to each other. Same idea here. 5 is to 7 as 35 is to 49. Kind of a mouthful, but much easier to write it as a proportion. 5 over 7 equals 35 over 49. And proportions come in handy in all kinds of different ways. A lot of students are very comfortable working with proportions because we see it a lot. So if we want to determine if the proportions are true, we can either reduce both or use a technique we call cross multiplying, which a lot of students are very comfortable with cross multiplying. That's a really common technique. So if we want to see is 6 to 11 equal to 18 over 33, there are several ways to do this. Some students will very quickly notice that 6 times 3 is 18, and 11 times 3 is 33. So they'll very quickly notice that these are equivalent ratios. You can also reduce 18 over 33 and make it 6 over 11 to see that those are equivalent ratios. The cross-multiplying technique some students prefer, especially when the numbers are not so clear to work with, and that is when you multiply the top of one ratio with the bottom of the other and the bottom of the first one with the top of the second one. It's called cross-multiplying. Some students will call it the butterfly technique because it kind of makes a butterfly when you're done. Notice we're crossing over the equal sign. And if I do 6 times, let me clear that out. If I do 6 times 33 in the calculator, and then I do 11 times 18 in the calculator, notice I get the same answer. So that also verifies that the proportions are equivalent. So is 6 over 11 equal to 18 over 33? The answer would be yes, it is. Same idea here. 6 over 12 equaling to 15 over 30. Now here, 6 times nothing, well, something but not a pretty number is equal to 15. And 12 times something but not a pretty number is equal to 30. But some students might notice that these both reduce to 1/2. 6 over 12 reduces to 1 over 2. 15 over 30 reduces to 1 over 2. So if you reduce both of them, you'll notice that they reduce to the same values. You can also cross multiply 16 times 30 and 12 times 15. 6 times 30, 12 times 15. And you'll notice that when you cross multiply, they come out to the same answer, which makes them equivalent ratios. So here we would also say yes, those are equivalent ratios, which makes a true proportion. And then the last one, 20 over 24, is that equivalent to 3 over 4? One thing we can do is reduce 20 over 24. That would reduce to 5 over 6, which is not 3 over 4. So you might reduce both to say no, they're not equivalent. Let's try the cross multiplying technique and see what happens. If I multiply 24 times 3 and then 20 times 4, they will not be the same number. So 20 times 4 is 80, and 24 times 3 is not 80. So if they're not equal to each other, that's another indication that they are not a true proportion. So the first two are proportions, the third one is not a true proportion. All right, we're going to use that same technique of cross multiplication to solve for missing pieces. And again, most students are pretty good at this. It's something that you do in grade school quite frequently. So if we have 3 over 5 equals something over 40, some students will notice that 5 times 8 is 40. So if I multiply 3 times 8, I'll get the answer 24, which is fine. Sometimes it's not a nice clean multiplication like that. So let me show you the other way to get to that same answer. If we cross multiply 3 times 40, that gives us 120. Set it equal to the other direction, 5 times x, and you have a very simple equation to solve. 120 equals 5x. And what you can do with that is divide both sides by 5. And 120 divided by 5 will also give you 24. So either way, the answer is 24. Let me section this off. I always forget to do that. If your work tends to get messy, it's good to kind of section off each problem so you don't get mixed up in which section is which. So same idea on the second one. Some of you might notice that 16, so we have 16 over x equals 32 over 20. You might notice that 16 times 2 is 32, and so something times 2 needs to be 20. And so you might be able to figure out that x is 10. If you're not that quick or you don't really like the multiplication technique, you can also cross multiply here. 32 times x equals whatever 16 times 20 is. I think it's 320. And then again, you have a quick, easy equation to solve. Divide by 32. And you should get 10 as your answer. So you can multiply at top and bottom, or you can cross multiply and get to your result. This third example on the top row is one that is not so easy to use multiplication. So 6 times what is 15? Some decimal that we don't need to worry about. So this one, it's much easier to cross multiply. 10 times 15 and then 6 times x. So 6x equals 10 times 15 is 150. And then all you have to do is divide by 6. And 150 divided by 6 is 25. So sometimes the little top and bottom multiplication doesn't work, and so your only option is to cross multiply. And I think you'll find that that's a really quick and easy way to always get your answer. If you feel comfortable, you can pause the video and try the bottom 3, or you can watch me. Here we're going to do 28 times 9, and you can use your calculator in this section, so don't hesitate. 252 equals x times 21, which is 21x. Then we'll do 252 divided by 21. And then we'll get 12. So x equals 12. So cross multiplying is the way to get to these answers. The next one, x over 8 equals 3 over 5. We're going to cross multiply here, cross multiply here. 5x equals 8 times 3, which is 24. Divide by 5. This will not work out to a pretty answer, but that's okay. It's just got a decimal, 4.8. So x equals 4.8. And last but not least, 14 over 11 equals x over 3. Cross multiply again, 11 times x. And then 14 times 3. It does not matter which side goes which diagonal. It's an equation, so it doesn't matter. I tend to mix it up, so top and bottom on one side and then top and bottom on the other. It doesn't matter. 14 times 3 is 42. 11 times x is 11x. Divide by 11. And x equals, so you get a big crazy decimal. It will tell you how to round. It's usually to 2 decimal places. So this would be 3.82. I'm going to round to 2 decimal places. It will tell you in your homework how to round. This is going to be 3.82. So that's just proportions. When you set them equal to each other, you can cross multiply to find missing pieces, and that's a very powerful tool, as we'll see in the next 2 sections. It's a very, very powerful tool to be able to cross multiply and find missing pieces for proportions.